This poster presentation will be covering motor unit recruitment in wrist extensors and flexors as evidenced by EMG. A motor unit consists of a nerve and the group of muscle fiber it supplies. We can measure their activity using EMG, which reports the action potentials they create in the whole contracting muscle. As stated, EMG measures presence of electrical activity, not force, during concentric and eccentric contractions due to the numerous factors influencing force production such as change in moment arms and joint angles throughout movement. In this experiment, we wanted to gain information about what proportion of motor units might be active in wrist flexors and extensors during isometric, concentric, and eccentric contraction. Specifically, when do humans recruit the most motor units? I hypothesized that concentric contractions will give the greatest EMG amplitudes. Our subjects consisted of first-year DPT students ranging in ages from 22 to 34 years. Our subjects were all healthy, but students were not allowed to participate if they had a latex allergy or alcohol sensitivity. We prepared subjects for EMG use and had them rest their arms at a 90-degree angle on a table. Their maximum voluntary contractions were taken by having them flex/extend their hands against manual resistance provided by another student. EMG signals were picked up by electrodes and the resultant voltages were displayed on a computer which identified the largest peak for us to use as our reference MVC. Peak EMG values for flexors and extensors were then taken during each of the three contraction types. We used an 8-pound dumbbell and had subjects contract over a duration of 5 seconds, during which the electrodes and computer stored peak EMG values. After, an outside source calculated the means and standard deviations of percent MVC for each muscle group for each type of contraction. For wrist flexors, we found that concentric contractions produced the highest percent MVC for 6 of the 8 subjects, and for wrist extensors, it produced the highest percent MVC for 5 of the 8 subjects. So overall, our hypothesis was supported. In fact, results from numerous EMG studies support that concentric contractions produce the highest EMG amplitudes. But why do we think this is? Well, as a muscle eccentrically contracts, tension is loaded onto passive elements. Lonamo suggests that this sensory information is relayed back to the brain, which then inhibits muscle MUs in order to prevent damage due to tensile forces. Inhibition would lead to fewer MUs firing, more passive muscle fibers, and thus smaller percent MVC. I theorized for isometric contractions that there are smaller percent MVC values indicating less MU activity because muscle only has to produce enough force and recruit enough MUs to counteract the external force, not overcome it, such as in concentric contraction. So why should physical therapists care? Well, we can extrapolate that more MUs and thus muscle